Is negative feedback a better biological system than positive feedback? Negative feedback loops within the human body work to regulate homeostasis and maintain the required equilibrium for the body to be able to function properly. Where positive feedback loops work to amplify a system and increase the reaction to a certain stimulus, negative feedback loops work to inhibit that response. Negative feedback loops control the body's chemical and electrical outputs that either cause a reaction to occur or are stimulated by the reaction itself, regulating the body's response to certain stimuli. Negative feedback loops are important for functions such as thermoregulation, maintaining the correct temperature within the body to ensure that certain enzymes can complete their tasks. Without the assistance of negative feedback responses such as perspiration, the human body is subjected to an undesirable spike in temperature that can cause enzymes such as ones in the stomach to denature and can be rendered unable to catalyze specific reactions. Digestive enzymes and other such enzymes within the body are imperative to ensuring the prolonged survival of the human.
Positive feedback loops are unable to regulate the system as they are not designed to do so. The function is to increase reactions to certain stimuli to protect the body from harm. Without a balance between positive and negative feedback loops, the body skews toward entropy and cannot perform basic functions imperative to life.
As a biological system, negative feedback loops play important roles in the regulation of the internal biome, but their function as regulators does not make them more necessary than positive feedback loops that act as amplifiers. Equilibrium is about balancing the responses within the body to maintain the correct environment needed for it to function correctly. Neither system is more important than the other, as there is no regulation without amplification.
The brain is a very complex circuit of positive feedback loops, routing electrical impulses from one side of the brain to the other. In conditions such as Alzheimer's disease, these feedback loops are unable to communicate properly with the separate hemispheres of the brain due to accumulation of tumours and tau tangles. The destruction of these loops affect the sufferer's ability to complete simple tasks, remember things, and regulate their behaviour.
Alzheimer's most commonly affects people over the age of 60 and is the most common form of dementia, affecting 70% of people diagnosed with the condition. Early symptoms of dementia include short-term memory loss, which is attributed to the degradation of outer brain tissue, and an inability to regulate self-control, which comes from being unable to remember things that have recently occurred. There are two types of Alzheimer's, familial and sporadic. Familial Alzheimer's is the result of a genetic mutation and predisposes a person to developing the condition if one of their relatives has been diagnosed with it.
Whereas sporadic Alzheimer's is the development of the disease without any predisposition or familial history of the disease. The lack of interaction between familial Alzheimer's and sporadic Alzheimer's has led to questions on whether or not the disease can be classified as an infectious disease. It is possible that the development of the disease can be attributed to an accumulation of microorganisms around amyloid proteins, forming plaques that eventually begin to disrupt synapse pathways. These plaques are generally found in abundance around the hippocampus, which is the part of the brain responsible for memory formation and regulation, the cerebellum, which regulates behaviour and emotions, and the motor cortex, which controls a person's ability to perform tasks.
Diet and lifestyle can affect the development of Alzheimer's, diets having been formulated to slow the progression of the condition, but there has been no confirmed cases of such diets being overly beneficial. Medical tests aiming to create drugs to slow or even stop the progression of this disease has been unsuccessful, the most recent of which being a drug that aimed at combating the production of amyloid to slow the production of synapse and distributing plaques. There are two main theories as to how a person develops Alzheimer's, one being the production of the amyloid itself, and the other being the accumulation of microorganisms that form colonies on the synapse.
Since the failure of the amyloid prohibiting drug, the main theory regarding amyloid as the main cause of brain tissue degradation and synapse disruption associated with Alzheimer's has been disregarded. The reached hypothesis is that the development of Alzheimer's cannot be attributed to the production of amyloid or the accumulation of microorganisms alone, instead being a consequence of both. Amyloid is produced in the human body in the bone marrow, and it is possible that it is removed from the system before it has a chance to accumulate and cause harm prior to the development of Alzheimer's.
The likelihood of Alzheimer's being an infectious disease is very low, as it cannot be transmitted from one person to another through direct or indirect contact with an infected person. If the condition is attributed to both amyloid and microorganism colonies, it is possible that Alzheimer's is not a transmissible disease but a developmental one. Without enough evidence that the disease can be passed from one host to another through contact, the only proven way of contracting it being through genetic mutation, Alzheimer's is more likely to be a non-infectious disease, developmental disease.
I really don't think that the development of Alzheimer's can just be attributed to either the amyloid or microorganisms. I think that it's kind of a combination of the both, and a weakened immune system, since it shows up more in people of a certain age group, like 60 older people.
So what you're saying is that the pre-existing microorganisms that are already in your brain activate your immune system as it gets weaker and becomes more sensitive to all these outlying systems.
Well, I would think so. I mean, we produce amyloid in our body. We produce it in our bone marrow. And just like the body produces urea, which is really bad for us if we have an overabundance of it, it might produce the amyloid and then flush it free. And then as our immune system is weakening as we're getting older, we've got these microorganisms that once weren't harmful to us now clinging to this open buffet of dangerous chemicals that we haven't removed.
So not necessarily is it the main amyloid-heavy theory of Alzheimer's or the microorganisms fault themselves, but a combination of the microorganisms and the fact that your body, as it ages, is getting weaker.
Well, I definitely think so, because there have been studies that show that as your immune system gets weaker when you get older, you're more likely to develop autoimmune conditions, things like leukemia or get diagnosed with lupus. And with Alzheimer's, it could just definitely be a really, really bad side effect of our immune system breaking down. Like, you can't pass it on, but your body's deteriorated to the point where it's no longer able to fend off things that it once would have been able to.
So, in conclusion,
Not an infectious disease.
not infectious, but taking advantage of a weakened body.
Definitely. Don't do Alzheimer's, kids. Thanks for coming to our TED Talk. Don't do Alzheimer's.
If you want more information on Alzheimer's, contact your local GP.
We're not doctors. We're Year 12 students, so please do not follow any information that may have been given in this. If you think you have Alzheimer's, please see someone who can actually diagnose it, not us. Download this podcast everywhere. Unless there is nowhere to download it, then don't.